So here we're going to take a look at adding and subtracting rational expressions. Again, remembering that rational basically just means fractions. Believe it or not, adding and subtracting rationals is harder than multiplying them, which is why we usually study that first. So again, it's always a good idea to remember how to do these things in numbers before we try to do with algebra. So pretend I want to just add 6/5 and 2/5, right? Okay, yeah, just want to make sure you got this down. So remember, the numbers on the same are on the bottom are the same, and then I add the ones on the top. So 6 plus 2, not to put too fine a point on it, 8/5. Good? Okay, if this is confusing, you need to go learn that other stuff first before you do this, okay? What if I had something like this, though? What if I had 6/5 plus 2/3? Okay? Now we learn in grade school that we have to have the same, what's it called on the bottom, denominator. So we would probably go for 15 in this case, right? And to get from 5 to 15, I have to multiply by 3, so I have to multiply the top and the bottom by 3. And to get from 3 to 15, I have to multiply the top and the bottom by 5. So 6 times 3 is 18, and 2 times 5 is 10. So now that the numbers on the bottom are the same, I put that there, and 18 plus 10 is 28. And again, I've got that. All right? So we can actually do the same thing with rational expressions. So let's give you kind of a simple, I hate to use the word simple because nothing is ever truly simple, example. If I had 6 over x plus 2 over x plus 2. Really, it's the exact same thing. Just the idea, in fact, let me make it even more straightforward, is to say, what if I had 6 over x plus 2 over x? All right, the number on the bottom is the same, it's x, and so I just do 6 plus 2, or 8 over x. And again, like the example I just had, if I had this plus 2 over x plus 2, as long as the numbers on the bottom is the same, as long as the numbers on the bottom are the same, all I have to do is add the numbers on the top. And of course, it doesn't change if I do a subtraction, so 6 over x plus 2 minus 2 over x plus 2. The number on the bottom is the same. 6 minus 2 is 4. Okay? So just to make sure that you're really comfortable with this, let's do a little bit more with it. Let's try, say we had 5x. So we had 5x over 2y plus x over 2y. So again, the numbers on the bottom are the same. Then it's 5x plus x, and you don't even have to write out this middle step. I'm just doing it so I can be sure that you know what I'm talking about. 6x. Okay. Now I can do some simplification. I can say x divided by 2 is 3. So that gives me 3x over y. Okay, and let's do another one. Let's try 2y over 2x plus 7 minus, no, 2y plus 7, minus 7 over 2y plus 7. Again, the number on the bottom is the same, and then I just do subtraction on the top, 2y minus 7. Now on this one, note that we have the same thing on the top and the bottom, so in fact they both cancel out, leaving us with a placeholder on the top and a placeholder on the bottom, so that really just simplifies to 1. Now when you're doing subtraction, it's important to watch your parentheses. So for subtraction, it's really important to watch your parentheses. So for example, if I had a problem, in this problem here it didn't matter because it was just minus 7. But if I had something that was slightly different, say I had this, okay, all right, so there's my minus sign. Now, the numbers on the same, just again, the numbers on the bottom are the same. On the top, I'm going to say 2y minus 7 plus y. But it's important to note that that 7 plus y, all of that is getting subtracted off. So to indicate that, I really need to use parentheses. The parentheses are important because now I'm going to distribute that negative across to get 2y minus 7 minus y over 2y plus 7. And then that's going to reduce down to y minus 7 over 2y plus 7. Now where this can be fun is if you've got like simplification and stuff like that to do. And again, of course, you always want to watch your parentheses. So say I had 3x squared plus 2x, all of that over, and it kind of needs to move up here, all of that over x minus 1. Then you want to subtract off 10x minus 5, all over x minus 1. Okay, so since the number on the bottom is the same, that's good. The number on the bottom is the same, x minus 1. Okay, so on the top, I have 3x squared plus 2x, and I want to subtract off the entirety of 10x minus 5. I have to be very careful to include my parentheses so I can distribute that negative across. 3x squared plus 2x minus 10x plus 5, again being very, very careful with that negative sign, and x minus 1. Now the next step is to go ahead and simplify the top by combining like terms and going like that. And so then I want to see if I can factor out the top. Let's see what I can do. One of these is going to have to be a 3x, the other is going to have to be an x. Because this is a positive and this is a negative, that means both of these are negative. And the only factors of 5 are 5 and 1. So let's see. This one could be a 5. Yeah. And this one will be a 1. So let's check. Outer, inner. That gives me my negative 8x. So all is well and good. I'm going to go ahead and delete that because it's just going to get annoying. And I'm actually really excited that that's half factored because now the x minus 1 and the x minus 1 cancel. If you don't know what I'm talking about, you can review other lectures that will go over that. And then I got 3x minus 5 over a placeholder of 1. Anything divided by 1, that's just kind of a silly thing to have there. So I've got 3x minus 5. Lol. Alright, so let's just do one more for good measure. Try 4x squared. See if you can do this one on your own after we write it up. Pause the video and go see if you can work it out independently. Just to make sure. Notice we're not really doing any addition ones because they're reasonably trivial. Where this does get hard is when you don't have this common denominator, which we should also talk about. So since they have the same number on the top, on the bottom, both of them, that's my common denominator. So I have 4x squared. Sorry, I forgot to kind of tell you to turn it off, but turn it off now while you still can. Go work on the problem, make sure it makes sense. Again, I'm subtracting off the entire quantity of 8x plus 15. So I go ahead and distribute that negative. 4x squared plus 15x minus 8x minus 15 all over x plus 3, giving me 4x squared plus 7x plus 15 over x plus 3. Now, I've been doing this for a while, so whenever I factor this guy out here on the top, I'm pretty sure one of those factors is going to be x plus 3 because I'm going to want to cancel it out. So if that's x plus 3, this guy would have to be the 4x. And then 5 times 3 is 15. That's another way to do it. And then to do an actual check. So outer. Also, see, that wasn't right. Oh, that's because I hold a negative sign. I miscopied the problem. Woot! So that's why we checked, because that was actually completely wrong. So then this would have to be a negative sign. And like I said, you don't have to do it that way. You can just factor this like you've always factored it. I'm just saying that you can probably guess that one of the other factors that you see in the problem is going to appear in your factoring. So now I've got 12x minus 5x, and that does give me 7x, which is what I have in the middle. So my x plus 3's cancel, and that ends up with 4x minus 5 over 1, which is a placeholder, giving me 4x minus 5. Woot.